Alright guys, so we're going to explore 4.2 sine and cosine laws for obtuse triangles. Let's look at example 1. Determine the measure of angle A to the nearest degree. So we have a triangle, triangle ABC, and two sides are given to us as well as one angle. So since we have a side and its opposite angle as well as another side, and we're trying to find this angle A over here, we're going to use the sine law. So let's write out what the sine law is. Remember that the vertices of the triangle are labeled by capital letters and the sides are little letters, so little b, little a, and this would be little c. Alright, so let's write the sine law down like we said we were going to. So we have that A over sine A equals B over sine B. So now let's fill in the equation with values. So little a is 65. So we have 65 over sine A equals 40 over sine 23. And now to find out what sine A equals, we're going to cross multiply. So we multiply these two and divide by 40. Go ahead, pause the video and try that now. Then we get that sine A is equal to 0.6349. Therefore, angle A is equal to 39 degrees. So I want you guys to try that on your calculator to make sure you get the same answer. But if we look here, we notice that angle A is actually an obtuse angle, and what we got was an acute angle for angle A. Remembering what we talked about in 4.1, we know that sine of A is also equal to sine of 180 minus A, if A is an obtuse angle. So angle A actually equals 180 minus 39, which is 141 degrees. And that's your answer. Okay, let's look at the next question. The roof of a house consists of two slanted sections as shown below. I'll give you a minute to read that question, so pause the video, read the question, and we'll analyze it in a second. Alright, so I've drawn the roof of the house, redrawn it as a triangle over here, and we're looking, and it's not labeled, so any triangle should be labeled. So I'm just going to go ahead and label this A, B, C, and we're looking for angle C, and we have 1, 2, 3. We have a side, side, side situation. We're going to use the cos law. Okay, so this is the cos law. C squared equals A squared plus B squared minus 2AB cos C. We're looking for this angle right here, C, remember? Alright, so we filled in the values. So little c is 33.5, A is 17 because it's across from angle A, and little b is 20.3 because it's across from angle B. Alright, so what we have to do is first we need to figure out what the answer to this is first, and then what the answer to that is first. We cannot combine this and this together because this has a cos C attached to it and this doesn't. So we get, alright, so 33.5 squared gives us that. That's where we get the number. 17 squared is 289. That's that. And this whole thing right there gives us that. And then we're left with cos C. So what we're going to do is we're going to move the 289 and the 412 over to the other side. So because we're moving them over to the other side of the equal sign, the sign changes, so it becomes take away. And then on the left side, we're actually left with negative. I forgot the negative sign. There we go. Negative 690.2 cos C. So now we're going to divide both sides by 690.2, negative 690.2. On this side we cancel out, and on this side we get that negative 0.61 equals cos C. So angle C equals inverse cos of negative 0.61, which equals 127.6 degrees. And it's an obtuse angle, so that makes sense. Alright, good job. Alright, let's look at the final question here. So we have Colleen and Juan observe a tethered balloon advertising the opening of a new fitness center. They're 250 meters apart, joined by a line that passed directly below the balloon, and were on the same side of the balloon. Juan observed the balloon at an angle of elevation of 7 degrees. Remember, angle of elevation is going up. While Colleen observed the balloon at an angle of elevation of 82 degrees. So this is Colleen's angle right here, and it's 82 degrees. Determine the height of the balloon, this red dotted line, right here, to the nearest meter. So basically we have two triangles that we're working with. We're working with Juan's triangle, right here, A or JBC, and we're working with Colleen's little triangle here, BCD. Okay, so let's draw out Juan's triangle, JBC. So there's the triangle, okay, JBC. We know this angle down here is this little angle 7. We don't know what this angle here is, but we know that the outside angle, the exterior angle to that is 82, and these two angles are supplementary like we learned earlier, meaning that they have to add up to 180. So that would make this angle in here 98 degrees, and since all angles in a triangle add up to 180, this last angle is going to be 75 degrees. Alright, now we know the bottom here is 250, and we're trying to find this length right here. That's our first step. Find the length of JB. Okay, so we're going to use the sine law for that, because we have an angle and the unknown side x, and another angle and our known side. So we have x over sine 98 equals 250 over sine 75. We're trying to solve for x here, so we're just going to cross multiply. So multiply there and divide by sine 75. So x equals sine 98 times 250 divided by sine 75. So go ahead and try that on your calculator, and you should get that x is equal to 256.3. So we're trying to find the height of the triangle, which again is this dotted red line right here, and we see that that line along with the 250, or not with the 250, along with this bottom line JD forms a right triangle. So let's redraw that triangle. So it looks something like that. We know in here that we have 7 degrees. We know now that, well, this is J and this is B. We know that JB from the previous part is 256.3. This is a right angle, and we're trying to find the height. Remember, we don't know the length of this bottom piece here, because just JC is 250, not JD. And C is up to here, and this is D. So now we just have a plain right triangle. We can just use normal trigonometry. This is the angle that we have right there, making this the opposite side. This is the adjacent side, and this is the hypotenuse. So we're going to use the hypotenuse and the opposite side. So from SOHCAHTOA, opposite of hypotenuse is sine. We have sine 7 over 1 equals opposite of our hypotenuse. And now we just fill in with the numbers. So we have sine 7 over 1 equals h, the height, over 256.3. And now we're just going to cross multiply. So multiply there and divide. And we get that h is equal to 256.3 times sine 7 divided by 1, which gives us that h is equal to 31.2 meters.